morning all, I am Mansi Pawar and I am pursuing my MSc in Chemistry at IIT Gandhinagar. I completed my bachelor's from Delhi University. So today we will be studying about biomolecules. As we all know that every part of our body consists of various biomolecules like carbohydrate, amino acids, proteins. Our body is made up of proteins and kinases, that is. And that are terpenes, alkaloids. So today we will be shortly covering carbohydrate and amino acids only. So let us start with the carbohydrates. So what are carbohydrates? Carbohydrates are basically polyhydroxy aldehydes or polyhydroxy ketones. For example, polyhydroxy aldehyde, there are many examples like glucose, mannose, and polyhydroxy ketose. There is example fructose. So for first, we will be discussing about the classification of carbohydrate. We are doing the classification on the basis of number of molecules a carbohydrate give upon hydrolysis. After hydrolysis, and this classification is as follows. First, monosaccharides, that is containing only one carbohydrate unit, and disaccharides, name is suggesting itself that it will give two molecules after hydrolysis, and third one is oligosaccharides. More than 3 molecules after hydrolysis, but commonly we study about monosaccharides and disaccharides in our body, as they plays more important role as compared to oligosaccharides. So for example, let us take one example for all these monosaccharides. For example, glucose. Disaccharides, for example, sucrose. For the whole video, we will be covering sucrose as disaccharides for hydrolysis or forming disaccharides. And for oligosaccharide, examples are starch or cellulose. Starch and cellulose contain more than 10 units of monosaccharides, whether it is glucose, mannose, in a various conformations. So let's go ahead on the chemical part. Of reduction and oxidation of carbohydrates. So for that, let us take glucose. This is D-glucose. So let us discuss how we give the notations D and L. If here at C2 carbon, at this asymmetric center, the OH is present on the right side, then we give the configuration as D, that is dextrorotatory. If the OH is present on left side, then we give notation as L, that is levorotatory. And these shows the optical activity, that how they will rotate the plane polarized light. So let us come to the reduction and oxidation part of carbohydrates. So we are reducing glucose with the NaBH4 as a reducing agent. So when we reduce, the glucose converts to glucitol. This aldehyde unit is getting reduced to alcohol. It is CH2OH here, keeping other anomeric centers same configurations. This is glucitol. Let us see oxidation part here itself. So we are oxidizing glucose with the HNO3 as a oxidizing agent. So upon oxidation, this aldehyde parts get converted to acid. That is glucose getting converted to glucuric acid. Glucuric acid. That is aldehydes getting converted to COH, keeping the other notations same. This is our glucuric acid. So this is how we do the reduction and oxidation of glucose unit or any monosaccharide unit present. Now we will be coming to how glycosidic bonds formed in any monosaccharide unit. So let us form more glycosidic bond in glucose itself. We will be doing every reaction, every activity on glucose only. It is the most basic unit we have. So this is glucose again. And the lone pair of glucose attacks at this aldehyde carbon, making a hemiacetal ring. Hemiacetal ring. That we also called as pyranose ring, because this 6-membered ring is known as pyranose ring. So we form a pyranose ring here. First to make it like this. And this aldehyde is getting converted to alcohol, hydroxyl group. So let us see COH, H. This is forming ring here, and this is what we have is beta D glucose. And how we are forming beta? When we make a hemiacetal ring upon glycosidase, this hydroxyl group can take two notations. When it comes on the right side, it's alpha. When it comes on the right side, it is alpha D glucose, and when it comes on the left side, then it is beta D glucose. CH2OS. This is beta D glucose. And this carbon, where the alpha and beta notation is getting changed in two forms, is known as anomeric carbon, that plays a very important role in chemical activities. So this makes a pyranose ring. So we will be making showing a pyranose ring for alpha D glucose. So and this is the pyranose ring for alpha D glucose. For alpha OH will be downside, and for beta OH will be upside at this anomeric carbon. Others notations will be same. CH2OH. So here also this is alpha D and this is beta D. So this is how a glycoside bond is formed. Now we will be seeing that how disaccharide unit or polysaccharide unit undergo hydrolysis to give its substituents units. So here we will be taking example of sucrose again, that is known as table sugar found in everyday life. We will be drawing the structure for this disaccharide sucrose that contains alpha D glucose and beta D fructose. bounded with beta 1,4 linkage, with beta linkage. This is the structure for sucrose. This is beta D fructose, that is OH on upside, and this is alpha D glucose, that is OH on downside. So this is how we show the bonding. This is beta D glucose. This is alpha D glucose and beta D fructose. So on hydrolysis, we are doing hydrolysis in the presence of water. So what happened upon hydrolysis is this: the lone pair of oxygen attack at this anomeric carbon, forming this, and hydrolyzing both the monosaccharide unit into two separate molecules, giving one alpha D glucose and one beta D fructose separately. So this is what we have in hydrolysis part. So we will be seeing a single question for carbohydrate. So on the basis of what we have learned, we will be drawing the structure of beta L glucopyranose. Beta L glucopyranose. So how we will draw? First we will draw a glucose ring, that is glucopyranose ring, that is like this, and it is having beta, so it will be upside OH, H, and this L notation shows that at C5 position, this is C5, 1, 2, 3, sorry, this is C5 position, OH will be reversed as different than the C1 position. So let's see, CH, H, OH, H, OH, H. In beta D glucopyranose ring, we were drawing CH2OH on upside and OH on downside, but on the L notations, we reverse the notation configuration at C5 carbon. So here it will be CH2OH and OH here. This is the structure for beta L glucopyranose. So this is all we are covering for carbohydrates. There is a lot to cover in amino acid, proteins, terpenes, but this is all for it. Thank you.